What up, mathletes? Woo, woo, woo. All right, let's do this, y'all. Oh, I gotta move my camera over. Let's make this bigger. It's like I wasn't prepared or something. I don't know. All right, so what's happening here? I gotta move this up. We're talking about the Pythagorean theorem today. Our learning target is I will find angle and length measures using the Pythagorean theorem. It's going to be up in the learning target area right above this video. So make sure and get that written down in your notes. All right, let's get down to it. So what is the Pythagorean theorem? You guys have all seen it before. It's that whole a squared plus b squared equals c squared. Okay? Now we got to manipulate this to use it to solve for different leg lengths. Now, what you got to know about A and B? A and B are the legs. A lot of times we'll say A is the short leg, B is the long leg, but at the end of the day, it doesn't matter. What matters is you know that C is the hypotenuse, okay? And we have to have a right triangle, which we see going on right here because of our little right triangle box. Sorry, I got to get that coffee love in there, you know what I'm saying? But what if I just want to solve for C, which is X in this case, okay? So then I got to take the square root of both sides, and what do I get? Just like the distance formula, right? C equals the square root of a squared plus b squared. So in this case, what do we got? Take a minute, pause it, why don't you try to figure it out? All right, I'm going to have C equals the square root of 15 squared plus 8 squared. I always put them in parentheses. You don't always have to, but I do. If they're negative, you need to. So what's 15 squared? I don't know off the top of my head. I don't know. 10 times 15 is 150. Half of that is 750. So 2250, I think. I mean 150 plus 75, which is 225. I think it's 225. I don't know what I was thinking a second ago. See, 15 squared. Hey, it's 225. How about that? So I'm going to have this equals square root of 225 and then plus 8 squared, which is 64. And that comes out to be 289, which equals the square root of 289. And what is the square root of 289? I have no idea. So I'm going to use my calculator. 289. Boom. 17. So this becomes 17. You ready? It's about to go, 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 gone. So I can type it in. See how we did. Check, check. Boom. We did it. All right. So it's just a simple matter of solving using the Pythagorean theorem. Now it does get a little more challenging. In the following triangle, find the side length x. Well, in this case, let's go ahead and label them. I'm going to call this A. Again, it doesn't matter, A or B. It's up to you. And C. So I need to solve for A. So if C squared equals A squared plus B squared, right? How would I solve for A? Well, I got to get it by itself, right? Got to get this by itself, which means I'm going to subtract B squared from both sides. And I get that my A squared equals C squared minus B squared. If you noticed, I just flip-flop. So I could have A on the left. Again, we're going to take the square root of both sides. And now I have A equals square root of C squared minus B squared. See how we can manipulate the formula to be able to use it how we want it? And let's go ahead and plug numbers in. So I'm going to have my A equals square root, pardon me for not being the best mouse writer in the world, of what? C is 13 squared minus, that should be a squared, minus 9 squared. 13 squared is 169, so this is going to be the square root of 169 minus 81. Let's put the 1 first. 81. And what's 169 minus 81? Ooh, I did not get 9 minus 81. 88. So this equals square root of 88. And now the answer tells us to round to the nearest hundredth. So we know we're going to need to actually do the square root. So function square root 88, which is, so this is approximately 9.380. I'm always going to take it out to the thousandth. And then let's see what we got here. Ah, crap. Is it going to try to follow me around? So that 0 tells the 8 to stay the same. So your rate is about to be going, gone. So it's 9.38. Oh, 9.38. Let's see what happens. Hey, look at that. Awesome. Now I want to talk about some a little more challenging. Right here, guys, this is the same exact thing. I want to show you what I mean here. Find the distance between the points A and B below. I'm not going to solve it all the way because it's really identical to the last two problems, but I want to show you how we solve it, how we started at least. There we go. That's what I said before. So, do you notice I can draw a line? That is not a good line. You need to erase that one. Oh, it erased the whole thing. All right. I'm going to draw it in two different colors. Here. Oh, wrong one. There's my first line. That's not so bad. Let's try the next one. We'll go red for vertical. That's better. And here's what you need to notice. Get this out of the way. Find the distance between A and B and below given, or that is, find the length of the segment connecting A and B around your answer to the nearest hundred. So we're going to calculate this all the way. But if I don't know what this is, so we're going to call this X. What are my side lengths? Well, it says 1 unit, so I can just go, it doesn't really matter. I just go 1, 2, 3, 4, 5. So this is 5. And then to go up, 1, 2, 3, 4, 5. Oh, this is also 5. So now I have my A and B. I can put it into the C equals the square root of A squared plus B squared formula and solve for the hypotenuse. So I'm going to let you guys go ahead and do that. Ready, set, go. All right. I'm assuming you paused it. If not, do it now. But we're going to go through this. So I'm going to have that my X, which is my C, is going to equal the square root of 5 squared plus 5 squared, which that's 25. That's 25. So I have X equals the square root of 50. And what is the second function? Square root of 50. 7.071. So let's stop at the hundredths. Again, that 1 tells the 7 to stay the same. So 7.07. Gone. Another 7. And let's check it. Check. Hey. All right, let's work through this. I want to see out of these two problems. I was going to work only one of them. Let me see which one. Okay. This one, guys, I'll just talk you through a little bit. When you get to a problem like this, y'all, again, we have the hypotenuse, we have one of the legs, so you got to solve for one of the legs. So just know that you're solving for a leg and not a hypotenuse like we did in number 2. But this one right here, I'm only going to work out one of these. But remember, what do we know? To be a right triangle, it has to be that A squared plus B squared equals C squared. So in order to calculate this out, we're going to have, first of all, how do I know which is which, right? Well, when we're talking about a right triangle, guys, the hypotenuse is always the longest side, okay? The two other sides can be different lengths, but they're shorter than the hypotenuse. So you cannot have two high numbers that are the same value. So let's go ahead here. We look, the highest number is 14, so this must be my C value. And then it doesn't matter which one you call A or B, but let's give it a try. So I'm going to have 8 squared plus 11 squared hopefully equals 14 squared. Let's give it a try. So that's 64 plus 121. Hopefully equals, I have no idea what's 14. Oh, no, wrong button, wrong button. 14 squared. I'm using the calculator over here. Is 196. I recommend buy one or go to the library and check one out. I'm going to say no, because 64 plus 121, what is that? 185? That's not 196, is it? Nope. So that's not true. So we would say not a right triangle. All right? You're going to go on until you get through. Now, everybody notice, so here, let me take this off. Everybody notice this not enough. Sorry if you notice a blip in the video, but notice this not enough information section. That only applies if we're given a situation where maybe they give us two, that only applies if we're given a situation where maybe they give us two of the same number and they're the bigger numbers, or maybe they only give us two values or something like that, so it's not enough information to be able to determine what's going on. But I haven't seen a lot of that happening. Over here, they're all three different numbers, and so when you got that going on, you can pretty easily tell by doing Pythagorean theorem whether or not it is indeed a right triangle or not a right triangle. All right, with that said, that was terrible. I got one of those. Peace out. There we go. Still don't know why I do it. Good night. Good morning, wherever you're at, whatever time it is. Good that.